thought I'd just do a short video on trigonometry. Now trigonometry to me is like a way of showing how lengths of objects and things relate to one another and how they change. Trig is a way of showing how one length changes in relation to another, and the thing that varies the lengths is called the angle. It's always the part of trig that we're going to look at is to do with right-angled triangles. A right-angled triangle is obviously a triangle that has one angle that's 90 degrees, because the 90 degrees is the right angle. It makes a kind of L shape. It's like a corner, you know. And one thing that we have to know is what all the different sides are called. And the side that's opposite the right angle is called the hypotenuse, and it's also the longest side. It's always the longest side of a right angled triangle. Okay? But there are, of course, two other sides, because triangles have three sides. So which is which? And it's a trick question because we can't label them yet, and I'll show you why. Because say we've got two different points of reference here. We've got one compass this way round and another compass this way around. We've got a person here and a destination. Which compass bearing is the destination from the person? And we can't possibly say without choosing one of the two compasses to be the one that we believe in, because they can't both be right. So if we choose one of them, say this one, we can easily say that his destination is in the west bearing, or the westbound heading, if you like. And that's similar to triangles, because first of all, before we define what the lengths are called, we have to decide which angle we're going to use. You don't use the right angle. You can either use this one here or this one here, and it's just a case of choosing one of them. So we've decided our viewpoint, which is like deciding the compass that we chose earlier. If we say this one here is the angle in question, then we can then label the sides. So if this is our angle A in this corner, everything's in relation to that. So this side, which is directly opposite the angle, if you look at that straight line going here, this side is opposite the angle, so we call it the opposite side. This side is adjacent or next to the angle, so we call it the adjacent side. Adjacent just means next to. So all the sides are labelled with respect to the angle that we chose, apart from, of course, the hypotenuse is always the one opposite the right angle, and it's always the longest side. The hypotenuse to me is a bit of a crazy word, which just means the longest side of a right angled triangle. The opposite, like I just said, is the one that's opposite the angle in question, and the adjacent side is next to or adjacent to the angle that we're interested in. And there's something like a memory aid or a mnemonic called SOHCAHTOA or SOHCAHTOA, and what this does is try to explain to us and remind us the main trig functions. We've got sine, which is the so part, we've got cos or cosine, which is the ca, and the tangent function is toa. And what that means is the sine of an angle is the length of the opposite side divided by the hypotenuse. The cosine of an angle is equal to the adjacent side divided by the hypotenuse, and the tangent of an angle is equal to the length of the opposite divided by the length of the adjacent. So when we talk about lengths, they're the lengths of the sides of the triangle, and the sine, cos and tan functions are always functions of an angle. So when working with trig problems, we'll either be asked to find the sides of the triangles, like the length of those sides, or the angles in between the sides. And you should always be given enough information for the answer, otherwise it's not a proper question, is it? But then you may be asked to find further information once you've found out, say, two of the sides. You can find a third. To find or work out a triangle side length via a trig ratio, we need to know the angle and one other length. To find an angle, we need to know two side lengths. And the trig function we use, either sine, tan or cos, is completely dependent on which sides we either know or which sides we want to find out. And this will all make a bit more sense when we do some examples. And I call the sides that we want to know, or that we already know the lengths of, I call them the sides of interest, because the other ones aren't relevant to us. Trig functions are to find lengths, or more specifically the ratio of lengths, or how one length of a triangle side changes compared to another length. When the side lengths in question or of interest to us are the opposite side and the hypotenuse, we use the sine function. So the sine of this angle from SOHCAHTOA, the sine of this angle is equal to the length of this side, the blue one, divided by the length of the hypotenuse. And to put it in equation form, the sine of theta, where theta is the angle, or you could call it anything really, as long as you know that the sine function is always of an angle, that number that you get from putting sine of an angle into your calculator is equal to the length of the opposite side divided by the hypotenuse length. And usually you'll be given the angle and one of these two sides, so you can work out the other side. When the sides of interest are the adjacent and the hypotenuse, we use the cos function, because the cos of this angle, or the cosine of this angle, is equal to the ratio between the adjacent length divided by the hypotenuse length. And I say ratio, but it's ratio expressed as a divide sum, or what we call a quotient. So the cos of this angle, say this angle was 45 degrees, we would put cos of 45, press equals, and that would give us a number, and that number would be equal to how long the adjacent side is compared to how long the hypotenuse is. And if we know either one or the other, we can find the one that we don't know. And then for the tan function, or the tangent, it's the other two that we haven't done in relation to each other yet. Tan function, the tan of an angle is equal to how big the opposite length is compared to how long the adjacent length is. So the tan of an angle is equal to the opposite side divided by the adjacent side. And when we talk about sides, we're always on about how long they are. Just a sort of daft way of remembering the sine function. It's like a fishing line, if you like. This is the hypotenuse, and this is the opposite side. So how much fishing line there is compared to how long the rod is. If you imagine this guy lifting the rod up, as the angle increases, the amount of line from the top of the rod to the water will increase. So the sine of the angle is equal to the opposite length, or the length of the line, divided by the length of the rod. And of course, we know this is the opposite side. As long as we define what this angle is, we're fine. A simple way of thinking about cos, they've both got C on them. It's a croc's mouth. That's the adjacent, that's the hypotenuse. But a better way is to say, get a daft example like this. Imagine you've got light coming down from a long way away. Imagine there's a sunshade, and this is the shadow that's cast by the sunshade. And what we could say is the cos of this angle is equal to the adjacent length divided by the hypotenuse length. And here, the length adjacent to the angle is the shadow, and the hypotenuse, the longest side, is the sunshade. That's just one way of remembering. And for tan, it's a bit harder to come up with something to remember it by, but you could say it's always right, because it's like a right angle. It's like a set square for those engineers out there. It's like a bookend. So the tan of this angle, when we have to know what this angle is, the tan of it will just be a number, probably expressed as a decimal, say, and that number will be equal to how big this opposite length is compared to how big the adjacent side length is. And what we usually have to do is move the formula around a bit. We have to transpose, because we can be given an angle and then we can write, okay, the sine of the angle gives us, I don't know, 0.1 or 0.9 or whatever it is, and we know that that number is equal to the opposite length divided by the hypotenuse length. But then we need to do something with that, because we're either going to know this one, the opposite, or we're going to know the hypotenuse. But then to figure out what the unknown one is, we have to rearrange the equation. So we could say, from transposition, if the sine of something is equal to the opposite over the hypotenuse, then the opposite length is equal to the sine of the angle times the hypotenuse, just from rearranging. So if we want to know what the opposite side length is, and we know the hypotenuse, we know what the angle is, so we can find the sine of it, which will just be a decimal number, say, and multiply it by the hypotenuse length. But if we happen to know the opposite side length instead, and we want to find the hypotenuse, then the hypotenuse is just the opposite length, which we know, divided by the sine of the angle, which we also know. So there's always a way to find the unknown length if you know one of them and the angle in question. So just a quick recap. The three main trig functions, sine, cos and tan. The sine of an angle, and remember trig functions, it's the sine, cos and tan is always of an angle. Anything that follows the sine, cos or tan is always an angle. The sine one is equal to the opposite length over the hypotenuse length. The cos of the angle is equal to the adjacent length divided by the hypotenuse length. And the tan of the angle in question is equal to the opposite length divided by the adjacent length. And that's all very well if you want to find lengths and you know one angle and another length. But a lot of the time we want to find out what the angle between two lengths is. So this is when we start to use inverse trig functions. And there's nothing to be worried about. You just press the shift button before you do sine, cos or tan. And the angle in question for a sine function, the angle theta, is the inverse sine, or also known as arc sine, or sine to the minus 1, or on a calculator it's shift sine. So theta, the angle, is equal to sine to the minus 1 of opposite over hypotenuse. So if we know the opposite and we know the hypotenuse, we divide the opposite by the hypotenuse, and then do shift sine or inverse sine of what that number is, and it gives you the angle. And the way that I sort of think about all this inverse stuff, it can be a bit tricky, but if you think that say the cos of an angle, if we look up here, the cos of an angle is equal to the adjacent over the hypotenuse, think of that as the angle in another language, if you like. The cos of an angle is, say, like the angle in French, and we want to work out what the angle is in English. So what we do, we translate it from French to English by doing the inverse of the cos. So the theta, the angle, is the translation, or like, you know, going from cos language back to angle language. So we do this, the inverse function. And similarly for tan. If the tan of an angle is equal to the opposite length divided by the adjacent, then to find the angle itself, we do the inverse of the tan. We translate it back to English, if you like, into angle language. So theta, the angle, is inverse tan of opposite over adjacent. So you still use the same sides. It's just in these top three, we usually know what the angle is, and we know one side, and we find the other side by using these. But down the bottom, we assume that we know both sides in question, and then we divide them and do the inverse function to find the angle. That's all it is. So the sine function, just a quick recap again. If we know this angle and we know the hypotenuse, we can work out the opposite side. If we know the opposite and we don't know the hypotenuse and we know the angle, we can work out what the hypotenuse is with the sine function. Inverse sine finds the angle if we know both sides. Same for cos. you have to know the angle on one side to find the other side. And here we know this angle and we know that side, so we can find that side length. And the inverse function, you have to know both lengths to find the angle. And the same is true of tan. The only difference with sine, tan and cos, we're just talking about different lengths of the triangle, as in different side names. That's all it is. Everything else works the same. It's the same sort of format, if you like. Sine to the minus 1 is when we know the hypotenuse and the opposite. So we don't want to do it to death really, but I thought I'd show you these written out a bit more neatly once more. If we know the adjacent and hypotenuse, those two go with either the cos or inverse cos. So the cos of the angle is adjacent over hypotenuse, so the angle is cos to the minus 1 or inverse cos of adjacent over hypotenuse. And the same finally for tan. Tan of the angle is opposite over adjacent, so the angle is inverse tan of opposite over adjacent. So depending on what you want to know and what you know, there's always a way to figure out what you want to know using these functions. And hopefully you can go back over this video and have another look at it. And this is what we call a unit circle. It's a circle where the radius length is equal to 1, whether it's 1 meter, 1 mile, 1 volt, 1 anything. It can be any sort of unit, but we're representing the hypotenuse is equal to 1. And in our trigonometry, what you'll find is the hypotenuse, the longest side, is also the radius of this circle. So the radius of this circle, which is half of the diameter, is equal to the longest side of this triangle. It's also equal to the polar modulus. If you do polar complex numbers, it's the length, if you like, of the polar number, which is known as the polar magnitude. In electronics, the hypotenuse here is known as the amplitude or the peak voltage. And in a unit circle, all that means is the length of the hypotenuse here, the grey line, is equal to 1. And that makes things easier just to compare. It's easy to compare something to 1 or to compare it to 100%. Because of course 1 is 100%. It's 100 out of 100 is 100%, and that's 1. So this just shows, this little animation shows that as the angle increases, it tells you what the angle is in this little bracket. As the angle increases here, the sine function, as in how big the opposite compared to the hypotenuse is, goes up. And the maximum that the sine can be is 1. And cos is similar, but the cos is equal to 100% or 1 when the angle is 0. And tan is just the ratio of how big the red one is to the blue one in terms of the triangle sides. So just to quickly say that another way, so hopefully it goes in a bit better. The sine of this angle here, whatever the angle is, it happens to be 39 there where I stopped it. The sine of 39 degrees is equal to how big the red length is compared to the grey hypotenuse, opposite over hypotenuse. The cos of 39 is how long the blue line is, the adjacent, compared to the hypotenuse. And the tan of 39 degrees is how long the red opposite is compared to the blue adjacent. So they all just change in relation to each other, and here all it really means is the length of the triangle sides changing as the angle changes. But when you see it as words, it's really sort of off-putting, but that's all it really means. So I'll just do a quick example, only a few more slides left. I know this is quite a long video. Don't try this on holiday, of course, but I'm sure it does happen. A group of student doctors go on holiday. For a clinical trial, they decide to climb up a tree and swing from a rope attached to a pole. They're near a cliff edge, and if they time it right, they can let go and fall into the sea without hitting the cliff. And what we want to know is what's the minimum angle that it's safe to let go of the rope without hitting the cliff. So we've sort of drawn this here. The safest horizontal distance from the pole to the edge of the cliff, I know this is clipped off a little bit on the screen, the safest distance is 8 meters here. And if we choose this angle here to be our angle, that's when we can, once we've chosen our point of reference, we can then label all the sides of our triangle. So they climb up this tree, they swing, and then they let go at least here at the earliest. And we want to know what's this minimum angle that they can let go of the rope. So let's zoom in on the triangle and draw it out a bit better. So choose the angle first. You have to choose the angle, otherwise you don't know which side is the adjacent and which is the opposite. So we're going to choose this angle here to be alpha. And I suppose really you have to look at this triangle with your head tilted to the left now, because the side that's opposite this angle is this one. So this is opposite. So this is therefore the pole is the adjacent, and the longest side is the rope, is the hypotenuse. So the hypotenuse is 10 meters because the rope is 10 meters long. The distance from the pole to the edge of the cliff is 8 meters. So we know the hypotenuse and we know the opposite. So which trig function do we use? Cos has the hypotenuse, but it doesn't have the opposite. Tan has the opposite, but it doesn't have the hypotenuse. So the only function that has the two sides that we care about is sine. So we're going to use the sine function. So the sine of this angle is going to be equal to the opposite length divided by the hypotenuse length. So the sine of this angle is equal to 8 meters divided by 10 meters. So the sine of alpha, opposite over hypotenuse, which is equal to 8 meters over 10 meters. So the sine of the angle is actually the sine of 8 over 10. And 8 divided by 10 is 0.8. So the sine of our angle, which is our angle sort of written in another language if you like, is equal to 0.8. So what we need to do to find an angle, what we sort of harp on about, is do the inverse trig function. So we do shift sine of 0.8. Sometimes you see it written as sine to the minus 1. And the angle is therefore 53.1 degrees. All helped by our calculator, of course. Here's just one more quick example. We've got a truss holding up a lighting rig, and the instructions state that the maximum strength of this red truss here comes from when there's an angle of 45 degrees. So obviously you need to set things up the way they're meant to be set up. But the only truss available is 3 meters long. So we know this red line here is 3 meters long, and we know the angle here has to be 45 degrees because the instructions tell us. We need to figure out how far apart to bolt our two blue support trusses, if you like. So we need to know this gap here. And if we start to label our triangle, if this is the angle, then this side here is opposite the angle, and this side here is adjacent to the angle. And we don't want to know how high this is. What we are being asked to find out is how far apart should we bolt these two vertical supports, which means how far is this gap here. So let's work it out. Basically, going back to this triangle, we know the hypotenuse and we want to find out the adjacent. And the only trig function that's with respect to hypotenuse and adjacent is the cos one, well, the only main one anyway. So we're going to use the cos function. So the cos of the 45 degree angle is equal to the adjacent length, which we want to find out, divided by the hypotenuse length, which we know. So the adjacent length is the gap, and the hypotenuse length is the length of the truss. I'll just refresh your memory. So the cos of 45 equals this length, the adjacent, divided by 3 meters, the hypotenuse. So what we do is rearrange so that the adjacent is equal to the hypotenuse times the cos of 45. We put 45 in our calculator, press cos, and then it'll tell us that the gap is the hypotenuse times 0.707, which is the cos of 45 in degrees, of course. So the length between the two vertical supports is 2.12 meters. So now we know exactly how far apart to put these vertical supports. If this is 3 meters, this is 2.12 meters. So basically, guys, thanks for listening. I know it's been a bit of a whistle-stop tour of trigonometry, but you have to start somewhere, and hopefully you'll go back over the video, and any questions, just leave a comment. Alright, thanks for listening. Thank you, bye.